Hi, I'm Bill Duffin and welcome to the March edition of the NFSTC Forensic Update. This month it's all about small devices making a big impact. We start off with a chemical and explosive detecting sticker inspired by, believe it or not, butterflies. Scientists at GE Global Research developed a sensor that uses a molecular structure similar to the morpho butterfly's wings, which change their iridescent sheen in reaction to chemicals. Comparably, the sensor reacts to chemicals and explosives in the air by changing color. It then radios information to a handheld reader, notifying agents at places like airports or cargo ships of the potential danger. Researchers say their stamp-sized device will cost less than $1 to produce and will be significantly more energy efficient than the current desktop detectors. That's pretty impressive. When the Orange County Crime Lab needed a field-portable presumptive test for a new street drug, they turned to Dr. Richard Blair at the University of Central Florida. Dr. Blair developed a 3D printed handheld spectrometer using a smartphone's camera and cloud technology that is easy to use and cost effective. It works by mixing the unknown substance and a drop of ethanol on a prepared test strip. Once dry, the test strips are tested with an alternate light source and placed into the handheld spectrometer. The investigator then takes a photo with a smartphone from the viewport, and the results are analyzed on an app. Dr. Blair says the 3D printing allows for customization without much change to the bottom line, which is estimated to run about $218 per unit. Dr. Blair's team is actively seeking test volunteers. You can find his contact information listed in his website in the video description below. Another pocket-sized tool took top honors at the Federal Laboratory Consortium's 2015 Award for Excellence in Technology Transfer. Sandia Labs created a credit card-sized detector for farmers in developing countries to test animals for Bacillus anthracis, the bacteria known to cause anthrax. The $5 to $7 device makes this type of testing safer, easier, faster, and cheaper. The team hopes to use this technology to stem other types of disease-carrying bacteria, preventing outbreaks such as salmonella. A new technique using electron backscatter diffraction has been developed to recover destroyed serial numbers from metal objects, like firearms. Researchers at the National Institute of Standards and Technology, or NIST, hand-stamped X imprints onto steel, then polished them off. Using a scanning electron microscope, the X is still visible. While the technique is still in the experimental stages, NIST says it definitely shows promise. If you'd like to take a look at the report for yourself, click on the link in the video description below. Hair dye is often used by suspects to hide their identity, but thanks to research out of Northwestern University, that same hair dye could become evidence. Hair samples from suspects can now be rapidly tested using surface-enhanced Raman spectroscopy to not only confirm the presence of hair dye, but what brand of coloring was actually used. The team is very confident that this technique could be used in the field. You can read their full report in the American Chemical Society journal, Analytical Chemistry. Well, that's going to do it for this month. Be sure to follow us on Twitter and Facebook for more NFSTC and science news. For NFSTC, I'm Bill Duffin, and we'll see you next time.